So the module outline for this course is uploaded in the LMS. You can download it. So we talked about IoT networks and the main components of IoT networks in the last class. So basically, we require sensors, um, sensors to collect data, and connectivity. It could be wireless, wired technologies to connect to a device or a router that can connect connect our data to the internet. So basically, the features of an IoT network is having sensors, softwares, and other technologies that support in the purpose of connecting and exchanging data with the other devices and systems over the internet. So basically, we will discuss about all these as we go. So the goal of IoT is to create a more connected and efficient world by automating the processes and improving the decision making based on the real-time data. Basically, with IoT, we hope to achieve automated processes. It could be in our own, smart, homes, and it could be in our workplaces, and also it could be in outdoor environments, such as agricultural environments or industrial environments. So in all these locations, now what we're trying to achieve is we are trying to obtain automation in those places by using the IoT technologies in those environments. So I think basically we use IoT in our day-to-day life, right? So one of the main devices that we use in our day-to-day life is our smartphone. So with the with the smartphone, we have a lot of sensors that are embedded in it. So it has sensors and it has uh, processing units. It has embedded processing units, and it has ability to connect with the Wi-Fi, and it has the ability to connect with the internet, right? So connect to the internet. So it has the ability to connect to the internet via Wi-Fi, cellular connectivity, uh, uh, cellular technologies such as 4G, 5G, um, network architectures, and then it also has Bluetooth. So it has many, functions that enable us to connect it to the internet. Basically, therefore, a smartphone is something that that we can consider as an IoT device, which is having all these features that we mentioned: sensors, connectivity, and processing power. So this enables us to use the smartphone in order to obtain the information that we need in our day-to-day lives. So I believe that we have come to the stage that we cannot live without smartphones. So I think that if you are using smartphones, that means you are basically working, or you are using the IoT concept in your life. So I think in order to customize the experience and improve the features in smartphones and other related IoT devices, we need to know what is there inside the IoT devices. So that is where we come into play, where we try to build IoT devices using sensors, using processors, and connecting modules. So we discussed in the last class also regarding this example where I talked about the smart agriculture networks that we can use to give an update regarding the fields, agricultural fields that we have in the outdoor environments. So this network is able to get measurements of soil moisture, air humidity, temperature, ultraviolet sensors. Uh, and then, it has the ability to take measurements from these sensors and update that data to the network infrastructure. So they will also use connecting, communication technologies such as, LoRa, and like narrowband IoT, Wi-Fi, etc. So we'll be talking about these communication technologies in the upcoming classes as the time permits, and we'll be going into detail regarding those communication technologies. So first of all, we will learn the components of a certain IoT network, and then we will, learn in depth about each of these components that are required for IoT network. So basically regarding the sensors, we have multiple categories of sensors that we can use, and there are so many sensors out in the market today. So it's up to us to select the best sensors for our work and use them in the appropriate application to get the necessary information. So based on the application, we need to also consider situations for example, if we are going to measure temperature in water, we need to select a sensor which is waterproof in order to get the correct sensor measurements and make sure that the sensor itself does not get damaged in the way. So therefore, when we are designing some IoT devices that collect sensor data, then we need to consider the environment at which we are collecting the data. So basically, because of that, it's important to protect the sensor from the environmental issues and challenges that are there. So not only water conditions, but also there could be fire conditions that could occur near the sensors. So therefore, at that moment, we need to design our sensor with fireproof, temperature temperature proof, like containers, and then we need to design this sensor such that we protect the sensor from the temperature variations and fire threats. So because of that, at the sensor level, we need to consider the application, uh, uh, and we need to design the sensors at that stage. So after connecting our sensor measurements to a certain access point, uh, through a certain communication technology, the access point is then able to connect our data and send our data to the expected destination. So that will be done through the cloud, where we are able to send the data across multiple routers and switches to the destination node. So the destination could be in a remote location, and that person or that device can achieve the data from that location and easily monitor the environment from that location. Also, the devices are able to give a feedback regarding the data collected and send that data back to the IoT network. So basically, we will be talking about different applications in the upcoming slides. So as I mentioned in the last lecture, we are basically having a set of sensors from which we are going to collect some sensor measurements with regard to different parameters. Could be temperature, could be motion, could be any other like alarms or some kind of like some alarming situations that could happen due to noises in the environment, or some kind of uh, maybe in air quality variations. And you can you can decide based on the application. So we will be connecting our sensors based embedded systems. The sensor based embedded system will collect the data and process the data. So that system will be able to transmit the process data uh, to a certain access point. So the sensor plus embedded system is able to process the data and transmit the data to an access point. So I think process and transmit the data. So the gateway, that is the gateway of our IoT network, which could be a router, is there to collect the data from the IoT sensor nodes, and then transfer that data to the internet, and through that to the end destination. So we call this sensor plus embedded system normally a sensor node, and we can address both the processor and the sensor using this name, sensor nodes. The word node you can use. So basically, the sensor nodes will transmit the data to the router or switch, which acts as the gateway between the local network and the wide area network. So once the data is connected, or it is transmitted to the wide area network, the data will be transferred to the internet using a certain routing algorithm, and then that data will be sent to the cloud servers, which I mean, if it is the destination, that data will be sent to the cloud servers where the data will be stored. The cloud servers have like a very high storage capability, and therefore the large amounts of data can be stored. We can store large amounts of data in the cloud servers. Okay, so because of that, IoT networks normally prefer to use cloud servers to store their data. So the cloud servers also can, provide security to the data, and it can manage the data really well. So the cloud servers have their own security features, which enables us to protect the data from any kind of unauthorized devices accessing the data. And also it provides data management capability, which is like we can manage the data from remote locations. So we can view the data, and we can organize and manage the data as per our requirement by accessing the cloud server. Apart from that, we also have the ability to analyze the data and make future predictions if required. So we can analyze the data and make some future predictions about the data using the cloud server applications that are available. And we can get some useful information about the IoT network through that. So if you have any questions, please let me know. So in order to become an IoT designer, you have to, I think, have the programming knowledge, Uh, Basically, you have to know how to, customize, existing, programming like codes, and then apply it for your own application. And then you also need to, I think, know the latest technologies and tech trends that are there in IoT communications, and it maybe know about the like technologies that can be used for IoT networks. And then we can also compare, like we can compare, or we can do a analysis, so we can do a survey about the existing IoT technologies when we are designing our own system. So we can do a survey, and we can check about the available systems of IoT, and we can implement our own IoT networks based on that. And then we also need to use the existing IoT platforms that are there, such as uh, Google Cloud, AWS, Amazon Web Services based platform, and then Cisco platform, Microsoft platform, and so on. So user interface design skills also, you need to design the application of your IoT network such that the users can get the necessary information from your interface. So the yes, do you have any questions? When we talk about the popular IoT platforms, we have multiple in the market today. You can go through and you can try to, search about these IoT platforms whenever you have some time. So Amazon Web Services, Google Cloud, Azure, Microsoft, Cisco IoT, these platforms are available for your inspection and uh, for your learning. So you can follow courses provided by these uh, uh, companies, and you can get certifications of having, knowledge about these platforms. So as of now, there are many jobs that require your skill in Amazon Web Services, Google Cloud, Cisco, Azure, for their in their job roles. So because of that, I think it is better if you can follow the courses that are recommended by these companies if you want to get a job in, for example, in the field of cloud computing, networking, and then other jobs related to the trending topics in the cloud, such as, for example, cybersecurity, and then software defined networking likewise. In such an IoT platform, we need standards to ensure the functioning of the IoT network, and such standards are defined by the protocols that are there in the system for different activities in the IoT network. So from the place where we collect the sensor data, uh, and uh, uh, in the process of transmitting the data to the access point, there's a certain protocol that we need to follow if we are using this platform. So because of that, we need to understand their architecture, and then we need to follow the procedures that they have defined in order to connect our IoT devices to their platform, and correctly upload the data, and observe the data getting uploaded in the IoT platform. And after that, you can do analysis on the data and do the rest of the process. So anyway, if you are using a certain IoT platform, you need to follow the certain guidelines and protocols that they have defined for that IoT platform. So there are certain specific protocols that they are defining for their network, so that should be followed when you are using that platform. So basically, After that, we also have the features of scalability in IoT platforms, which means that we can connect like millions or like not millions, but like massive amounts of devices, massive amount of sensor nodes to this platform. So in IoT networks, we have massive amounts of sensor nodes because we want to, like try to monitor a certain environment in the most accurate manner. So, for example, if you are trying to monitor a paddy field, let's say, we might need to deploy like maybe hundreds of sensors, and those hundreds of sensors will collect the data, and they will collect the data frequently. So therefore, there are so many data that is collected during 1 hour. There will be millions of data collected from all these sensors. So that those data need to be uploaded to the system without any delay and without losing any data. So in order to achieve that this IoT platform enables you to connect multiple devices and configure the such devices into this platform. So anyway, it allows you to connect as much as the devices as you want to the platform, and update that data in their platform. Those IoT platforms also provide you security for the data, where the data will be encrypted and will be decrypted using special keys that they are using, and they will they will use encryption method to encrypt the data. But from that, they will also use other authentication methods, maybe user authentication methods to secure the data, such that only the user who's allowed or who's authorized to adjust or access the data will be allowed into the database. So will be allowed into the database that is organized, or that is managed by this IoT platform, right? So IoT platform has a database that that database will hold all the readings or the data that it's received from the sensors. So the data that is collected in the database will be encrypted, and only the user will be able to decrypt it using a certain security key. We will learn about security aspects in the later classes as well. Apart from that, the data will be analyzed using these IoT platforms. There are, as I mentioned you before, there are many companies who are doing these platforms. So there are, different methods that they are using to analyze the data. So the analysis process will be done through their own software applications, and they will ask us to upload our data and ask us like what is the analysis that we want from this data. So we just need to use the available infrastructure, and we can do the analysis. Apart from that, we can also customize those analysis according to our needs. Apart from that, they also provide us the tools to build our own software that can do the tasks like data analysis and data prediction. I mean data analysis and prediction of outcomes by developing our own application related to this IoT network. So that own application that we want to develop can be developed using the software defined kits, or like software development kits that they are providing us. Anyway, so there are so many advantages of IoT, as I believe that you also understand by now. We have seen during our introductory video also that there are many advanced use cases of IoT in our day-to-day life. So we talked about smartphones being an IoT device, and about the fact that the IoT device, which is the smartphone, can have many sensors related to, connectivity, connectivity and motion sensing, GPS or location sensing, likewise, and connectivity. So there are many sensors that are included and embedded in smartphones, which are used for different purposes. So the data collected can be also transferred to the other devices and apps through the internet, using the IoT technology. Apart from that, traditional mobile phones, which are not having the connectivity to the internet, are not considered as IoT devices, right? So there are some organizations that define the standards for IoT networks. So IEEE, or Institute of Electrical and Electronics Engineers organization, is one of the institutions that define the standards for the Internet of Things. There are also other institutions like Internet Engineering Task Force, International Telecommunication Union, European Telecommunication Standards Institute. So these institutes provide the standards for the IoT network. Network users and the IoT network vendors to design their network uh, based on the standards defined. So this is also very important, because it's easy for the industrial communities and academia from the universities to design IoT networks according to the standards that have been provided by them beforehand, so that all the designers will be following the same standards, and they will do their improvements and updates on these IoT networks by following the standards. So once that is done, it's easy for any company to develop the standards based products and sell it to the customer, because that kind of a product will be usable for the customer, because that device follows the standards that have been defined for IoT devices. Because of that, all the different companies will follow the same standards, and therefore the users will be able to use those IoT devices which are without much hassle and difficulty. So because of that, if like all the companies who are developing IoT devices are using these standards, it's easy for the customer to adapt to these devices. Otherwise, if different companies use different standards, then the customer will have to use different resources, and maybe power supply, and different modules to connect our appliances to these IoT devices. So in order to reduce that, these IoT these organizations have defined IoT standards for everybody to follow, such that all the IoT devices will have some things in common. Right? There are some unique features of each IoT device, but all the devices will have some features common. So in the last class, I think we discussed about the world's, some things about the history of IoT. So in the last class, in the introductory video, we saw that there was a person who introduced the word of Internet of Things. However, even before that, in the 1980s, the first IoT network was introduced by an application where we where the where the where some students used a Coca-Cola machine to get updates about the Coca-Cola availability in that machine. So they use the IoT technology to do that. They place some sensors in the IoT, in the Coca-Cola machine, and they connected this sensor node to the internet through a cable, for example, and then they connected this sensor-based node to the internet. So what they were able to do is that they were able to monitor the existence of the Coca-Cola inside this machine and the condition of the Coca-Cola in the machine, right? So they were able to monitor the temperature, and they were able to monitor the availability of the Coca-Cola bottles or cans inside this machine. So this is considered as the first IoT application in the world. So in the last class, we saw an introductory video regarding Kevin Ashton. The Kevin Ashton is the person who introduced this IoT concept. I think we watched a video in the beginning of the lecture last week where he explained that the Internet of Things is uh, is is uh, is used to describe a network connecting objects in the physical world, connecting objects that are there in the physical world to the internet, right? And he explained that you need sensors and you need connectivity to build an IoT network. So you need basically these two features, sensors and connectivity, to build an IoT network. Kevin Ashton is a person who named these kind of networks as IoT networks, Internet of Things. So he was the one who named this term, Internet of Things. He was the one who coined the term Internet of Things. He also developed some IoT networks in different places. So he actually proposed using radio frequency identification or RFID chips to identify products in a supply chain in the industry. So he proposed the usage of RFID chips to monitor the products in a product line in the supply chains. So you can basically, have a RFID chip placed on each of the products in the in the supply chain, in the manufacturing areas, and you can monitor the products which are going through the manufacturing process. So I think he was the person who developed that project at that time to track the products in the manufacturing area. So likewise, there are now IoT networks, that concept has developed. So many projects have come up, and now we can see that people are moving towards automating the data collection at the at the environment by using sensors and connecting modules. So they have placed sensors at the factory levels, at the and any other locations, and they collect data using sensors. So as the next steps, the world has taken many initiations to develop smart cities, and we can see such smart cities in developed countries such as like Switzerland, Singapore, likewise US. So all these countries are interested, and they are interested in developing these IoT networks. So as of now, we can see that Switzerland and also other countries in Europe, they are focusing, and they are developing already devices that are working with the IoT concepts. So basically smart city concept is very popular. Apart from that, we also have the smart home concept, where we have the smart home concept, where we develop like a system at home to collect all the information regarding temperature, then lighting, then security. Likewise, all this information can be collected through our smartphone, by connecting our smartphone to the network, which is connected to the sensors placed in the house in different locations for different applications, right? So smartphone, smart home, smart city, those concepts are basically relying on the IoT concept. And then when we talk about the future and what IoT will be developed into, we can see that we will have many innovations with IoT, with regard to IoT. So we will have like machine to machine communications. So machine to machine communications involve different, like devices, or like different devices transmitting data and receiving data directly without the assistance of any other access point. And then like talking amongst them. So this can happen in situations where we have communications between robots, for example. So if we have autonomous robots who are working in a certain industrial environment, then the robots, they can communicate between them directly, and they can get some task done. So these autonomous robots can be used for industrial scenarios, for smart home scenarios, where they will help the uh, help the humans to get the work done without any help. They will do the work by themselves. Apart from that, we also have like other concepts like Internet of Nano Things. Internet of Nano Things. Internet of Nano Things is a concept where we are using nano devices, right? Devices in the nano level, nano scale, which are very small uh, in our environment. So an example would be like monitoring of sensors, or monitoring of the condition in buildings, for example, right? We have like in situations where we have buildings, we have situations where we need to store sensors in the buildings, such that we can monitor the condition of the building, or we can monitor the like the infrastructure quality by using these sensors, right? So what I mean is, like, let's say we have a building which has many stores, or many floors. It has many floors, let's say, and we want to know like whether there are any problem uh, with the building, with the quality of the building. Likewise, we want to monitor the condition of this building. We can place these nano sensors at each point in the building, and monitor the condition of the walls and the quality of the walls. Likewise, we can monitor many things uh, using these sensors that are placed in the environment. So Internet of Nano Things, the speciality is that the sensors are in the nano scale level, so that they are very small, and we can put them inside the buildings, inside the walls, and we can monitor the quality of the walls and buildings using such sensors. So that is the one of the next future IoT developments. From that, wearable IoT means like you already, I think you already use this. We have IoT watches, IoT bracelets, IoT based, t-shirts. There are some t-shirts with IoT sensors. So whatever the, accessory that we can wear and we can connect to the internet, we call that accessory as wearable IoT device. So we already have some of these accessories in the market today. So that is one, outcome of the IoT. And then digital twins. Digital twins is another concept in the IoT environment, and which is also in the current trend, right? There's a high trend for this digital. There's the high trend for this digital twins as well. Okay, so digital twins are, I think, even in Sri Lanka, people are trying to replicate that. So digital twin is a concept where we are trying to, totally, like create a certain environment using some digital simulations. Okay, so for example, like let's assume that we want to check the performance of a certain process. That is right. We want to check the performance of a certain process that is happening in an environment which is far away from our, our location, right? Let's say we are here, right? Let's say we are here, and what we want to do is we want to analyze the performance, or we want to monitor the conditions of the environment that is there in the sea, let's say, right? So let's assume there's a area in the sea that we want to monitor. However, like if we want to do the monitoring, it would be costly, right? If we go there and do the monitoring, it would be costly, and it would be like consuming a lot of resources, right? Rather than, doing it for a long period of time, we can develop a similar environment using simulations in our own space. We can create a virtual, sea like thing, a virtual sea, which behaves as same as the actual sea. So this will like function just as the actual sea, right? With the actual environmental like effects, right? So it will take into consideration the environmental effects, and then it will behave accordingly, right? So once we create this virtual sea, then we are able to input some data and check, give some inputs and check the outputs of this system, right? So using the outputs that we observe, we can then propose some uh, technologies, or propose some products that can be used in the sea, right? We can propose some products that can be used in the sea environment, right? Use in the sea environment, and that we can actually implement in the sea environment, right? So so this is the digital twin concept, right? So currently, even in Sri Lanka, this digital twin development is done in some industries in Sri Lanka. So we have such companies already, like Orel, which is very near here, who are developing the digital twin concept for their industrial environments. Okay? So they create a digital twin of the environment, industrial environment, and they use that to check the performance of their production, right? So they do production of some, some sockets and switches. So they check the production using the digital twin that they have created, and they check like what are the drawbacks of the current system, and what are the necessary solutions, what are the necessary improvements that can be done in that environment, and so on. So this concept therefore is not something that is something that is imaginary. It is already getting implemented in even in Sri Lanka. So currently, actually, even Sri Lanka is having all these IoT concepts and the resources to develop these IoT networks. Apart from that, with the IoT enhancement, we also will see some advancement in the cloud computing scenarios. With the development of the IoT networks. Uh, then I would also like to discuss about this super IoT concept, where we have sustainable Internet of Things concept used, right? So sustainable Internet of Things means like we are using energy resources that are available in the environment to power up our devices. So what I mean by that is we can use the energy that we harvest from a radio and light waves for our uh, wireless information transfer and for our power consumptions. Anyway, like I know that this can be something very new to you. However, what I'm saying is that there are some devices that we can use that that will harvest the energy that is around it and use that harvested energy to transmit data, right? So there could be some sensors that have this inbuilt harvesting unit, energy harvesting unit, that can harvest the data that are available in the environment, out in the uh, environment, right? So harvest the energy in the environment. So there are like energy in the environment that is produced by light waves light waves radio waves, right? So these light waves, radio waves, they carry energy, right? So these light waves, radio waves, they carry energy. That energy can be stored using special hardware, using the units that are installed in the sensors. So this energy that we can collect can be like in the range of like millijoules. They might not be very large, could be very small scale energy. However, that small amount of energy is enough for us to do the functions that are there in the sensor node level, right? So in that case, the sensors based the sensor node is able to produce its own energy for its own functions. So in that case, we don't need to power supply this, we don't need to give power supply to this node. In that case, the sensor node can run on its own. The sensor node can run on its own, and therefore the sensor node uh, can be considered as uh, a sustainable solution, right? So therefore, these kind of sensor nodes are known as sustainable, sustainable nodes, and those sustainable nodes are valuable because we don't need to provide any extra power to them. Apart from that, next I will talk about the mission critical Internet of Things. So mission critical Internet of Things means that we will be using, we will be considering uh, the situation, and based on that situation, we will design the Internet of Things network. So, for example, mission critical means like emergency situations, and during those emergency situations we need to communicate the data with very low latency and with high reliability, right? So we need to transfer the data with low latency and high reliability, right? So in order to right, in order to transmit the emergency data reliably, we need to have high reliability in our communication, and we need to send that data very fast to the end destination, so that the end destination will know and will obtain the data very quickly and will be able to provide some feedback. So in that location, the efficiency of this network will affect the life of a person, right? Life will be affected, and therefore it is crucial that the performance that is expected from this network is maintained. So we need to maintain the low latency, high reliability conditions, and so that we can save the lives of the people who are using this network. Right? So basically, I'm not going to go to in detail regarding the characteristics of IoT networks. We discussed about that. So here I will give a brief explanation about the existing IoT devices which are very popular around the earth. So we have Alexa, that is proposed and developed by Amazon company. It is a voice activated IoT device used for smart home applications and so related applications. So it uses voice commands that we give to the device, and it do the processing in the cloud servers, and then it responds to the user request using the data that it can obtain in the cloud servers and in the internet. Then we also have Siri, the Apple Watch that has been developed by the Apple company in US, and it is also having so many functions, and it is a voice activated and intelligent personal assistant. So this application is widely used as of now in the world, and people are using it to get their daily work done. So in all those devices that are really popular, we'll be using at least one of the wireless technologies uh, that are really widely used, right? We'll be using wireless technologies to enable the devices that we discussed before, and also those technologies are used for these wireless, wearable IoT devices. So when we talk about these wireless technologies, we have basically many technologies that are in use. So some of the most popular ones are like Bluetooth, and then we also have another option called Bluetooth Low Energy. So those are two different types of technologies, not that different, but there are two types called Bluetooth Low Energy and Bluetooth. So the main difference between these two technologies is that normal Bluetooth is having high energy consumption than the Bluetooth low energy module. So Bluetooth low energy module is used for situations where we need high data rates and low energy consumption. And then when we discuss about the other technologies, other wireless technologies, we have cellular network wireless technologies, which require high power consumption, but gives high data rates. For example, in the gigabits range, and then it also is able to connect to an access network which is at a very far distance from the device level, right? So like a person who's having a smartphone can connect with a base station which is located maybe 1 to 2 kilometers away from that device, right? So this long range communication is possible with the cellular communication than other communication technologies, basically. So when we talk about Wi-Fi is not able to do like 2 kilometer range communications without a certain repeater, for example, right? So Wi-Fi is able to do some communication only within like a short range distance. And Zigbee is also something like that. Zigbee is also able to do some communication in its environment. However, it's like range of connectivity is lower than cellular connectivity. And it also has its own added advantages, right? It also has advantages with related to like power consumption, and it has lesser power consumption than maybe like mostly Wi-Fi. And then however, it has low data rates. So depending on our application, we need to select the best communication technology for our IoT network. right? So depending on our application, we can select the best one for our application, and we can get the performance that we need. We also have some technology called near field communication. Near field communication is also a communication that uses wireless technologies, and it uses low power and has a low data rate. And this is used mainly in like payments, when you contactless payments, and then it is widely used for doing payments and information transactions secure information transactions secure data transactions. So it is using some encryption methods and decryption methods that enable it to be more secure than other technologies. Apart from that, it can also verify the identity of the person who's using this technology by checking in the ID that is stored in the user device. Anyway, it can check the ID of the user device. Therefore, by checking the ID of the user device, it will make sure that the user who's authenticated to use this will do the transaction. And then so we will talk about the near field communications later as well, and regarding its secure features. Right, so NFC is used for secure money transfers or payments, right? So in order to do the payments, we need to verify whether the user is actually having money in their bank accounts or the account they are using for the transaction. Only verifying that transaction will be allowed. So this NFC communication technology has a way of determining the user's identity using the data it has collected in its through its communication. Okay. So anyway, after that, we also have RFID communication technology to detect devices and do like monitoring tasks. So for different applications, RFID is also used. So I think with that, I think I will end today's lecture. And with the ending note, I will also would like to mention that I have uploaded a certain assignment to the LMS. You can observe the assignment that I have uploaded, and you can submit the answers to that assignment. If you have any questions, you can let me know, and you can complete the assignment. Right. So with that, I would like to end today's lecture. So if you have any questions, you can ask. Otherwise, you can leave the lecture. Thank you so much.